Hey everybody, and welcome back to the Kohi game engine series. Today we're going to go ahead and knock out the Linux platform code, and we're going to get started right now. So before we jump into the video, I would like to take a second and thank the channel's partners, Eearslya and Wensheng. The partners are the highest tier of membership on the channel, so I thank you guys for your support. I'd also like to take a quick moment and thank everybody under the supporters section. All of you guys that are listed here on the screen, thank you very much for your support. It's greatly appreciated. If you're interested in supporting the channel, one way that you can do that is you can go ahead and click the join button below this video. If you'd like more information on memberships, I'll go ahead and post a link in the description below, as well as a card in the upper corner of the screen. With that stuff out of the way, let's go ahead and jump into it. Okay, so in the last video, we knocked out the Win32 platform, which you can see is actually disabled here because I am on my Linux platform at the moment. So today we are actually going to knock out the Linux version of this. So the first thing I'm going to do is go ahead and create a new file. I'm going to call that platformlinux.c, and I'm just going to copy everything here from the header file. Go ahead and include platform.h. Just take a quick second here to convert these all to the definitions. All right, and there we are. So last time, one of the things that we had to do was in our Win32 platform, we had to type def an internal state struct that contained our platform specific information. So that's the first thing that we're going to do on the Linux side. So our internal state structure is going to look something like this. Now, obviously we have all these types that we don't know what they are yet because we need to actually import some files. So the libraries that we're going to need, I'm just going to paste in all at once. And now I'm going to stop for a second and explain what all this stuff is. So the way that windowing works in Linux is a little bit different than the way that it works in Windows. In Linux, there is a client-server architecture that runs, and more often than not, that is called the X window system. Sometimes it's called X11, that's what this X11 is right here. And that refers to the server portion of the windowing system in Linux. And then there is also the client aspect of that, and there are two major clients that are used most often in most Linux distributions, and those are known as xlib and xcb. Now, xlib has been around forever. Xcb is sort of the newfangled framework that has been around for a little bit, but not quite as long as xlib. So xlib is basically more or less deprecated at this point, or at least close to the point of being deprecated. And xcb is sort of the standard way to go. However, there are some functions that are a lot easier to use, in my opinion, and better documented in xlib than xcb. So we're actually going to be using a hybrid between the two. And from the research that I've done, this is actually a somewhat common approach to this. I do not claim to be any sort of expert on Linux windowing or anything like that, but this is the system that I have set up and used several times, and it works well for me, so it is what I'm going to use. So we are going to use a couple of parts of xlib, but most of our stuff is actually going to be set up using xcb. And again, those are the clients, and they interact with the X server via this xcb connection right here. So we basically make a connection to the server. We keep a reference to the window, a reference to the screen, and some other things here having to do with some protocols that have to do with messaging. We also have this display here, which is, you'll notice that that is not following the same xcb naming pattern. That is because that is the X11 portion that we're going to be using. So I know that's all a little bit confusing, and I promise that this will make sense once we actually start diving into things. But without further ado, let's go ahead and jump into implementing this. The first thing that we're going to fill out, obviously, is our startup. And the very first thing that we're going to have to do, similar to what we did on the Win32 side, is we're going to need to set up the internal state. So Right here, we'll go ahead and fill out the internal state with our new structure. Again, this is internally defined within this C file, so it will not actually collide with the one over here in the Win32C. And seeing this, I actually need to block this out with platform-specific code, so actually let me do that before we go any further. So above all these includes, except for the platform.h, we need to do a if check to see if this is the platform Linux, and then obviously we'll close that off down here with an end if. Okay, that way this doesn't try to compile on Windows or Mac or any other OS. We are going to need a couple more includes here. We're going to want the logger just in case we run into any sort of weird issues. So I'm going to go ahead and include core logger. The next include is a bit of a conditional one, and it has to do with what is currently installed on this version of Linux that we're running, or the distro that we're running, in terms of sleep. So there's a couple different versions of the sleep that are out there. There's uSleep and then there's nano sleep. And so depending on what distribution you're running, you may find that one or the other of these will be used. So we're going to be handling both of those cases. And I'll explain that a little bit more when we get to that. But I just want to go ahead and get that included so that we don't have to worry about it later. Okay. We are also going to need standard library .h. We're going to want stdio, and we're also going to want string. And these are all going to be for the purpose of logging and memory allocations, things like that. Okay, so that should do it for the includes. So now we have all of our includes, our conditional code set up here to only allow this to be compiled on Linux. We have our internal state that is being created here. So let's go ahead and move on to finishing our platform startup. So now that we have our internal state created, the very first thing that we're going to want to do is we're going to want to form that connection that I was talking about to the X server. And so to do this, we are actually going to call xopenDisplay, and this is actually using xlib. And in this case, we're just going to pass null here because we don't care about this. But we're going to save this off as state display, which is going to be this guy right here, right? So this is the single object that we're creating using xlib. Everything else will be xcb. Okay, so once we've done that, we are going to make one more call to turn off key repeats. And that is because key repeats can actually get a little bit annoying when we go to process input later. So I want to go ahead and knock this out now. Now, one important thing to note about the way that xlib works, and this is kind of strange and very unfortunate, is this particular call to turn off key repeats is global across the OS. There is no way that I'm aware of to only do this for the current application. It's global. So if you run this and then don't turn it back on later, key repeats won't work until you actually reboot. It's super crappy, and things like this are one of the reasons that xlib is not commonly used anymore. However, for now, we actually need this. If any of you guys know a better way to handle disabling key repeats, please do let me know. Because unfortunately, XCB is, while it's new, the documentation for it is terrible at best, but more often than not, it's also non-existent. So anyway, with that, let's go ahead and move on. So next, we have our display object here, right? But we also need this XCB connection. Now, if you were just using XCB by itself, you would actually connect via XCB and the XCB API. But in this case, since we already have xlib and we're opening this display, xlib thankfully provides us a way to get this connection object from the display, which is why we're actually creating the display, because we can actually use the display to get that connection. And that call is getXCB connection, right? And so you pass it the display and it returns the connection. Unfortunately, there's not a way to do this in the opposite fashion, so I can't create a connection and get a display from it, which is the reason we have to do it this way. Again, unfortunate, but that's the way it is. Okay, so before we go any further, we want to make sure that there are no errors present, right? Because if we have an error at this point, we can't continue with the application. It means something is wrong with the installation of the X Windows system, or there's something going on with the OS. We can't actually form a connection. to the X server. So if that happens, we're going to log a fatal message and return false saying, hey, we can't actually successfully connect to the server, so we have no window, we can't continue with the application. So next, we are going to retrieve some setup from the X server via this XCB get setup, and you'll see where we'll use that in a moment. And the next thing that we're going to do is we're actually going to loop through all the available screens using an iterator. And this is a little bit of a strange interface, but basically this is how we actually iterate through the available screens on the machine. And so actually it looks like for some reason I've got this screen P up here. So that actually belongs down here. So I'm going to go ahead and move that. Okay. So we have to make this call, because if we don't make that call, then we actually have no way to set the actual screen, which we're going to need here in a moment. So once we've looped through all those, we basically are iterating through this backwards, which will give us the individual screen itself, which is accessed through it.data, which is our iterator, right? So we keep a copy of our screen. And again, this is a bit of an unfortunate interface in terms of how this is set up. It's a little bit strange to me, but if you don't iterate through this, you have no way of actually getting the screen. The next thing that we need to do is we need to generate what's called an XID for the window. It's just an identifier for the X window. And we generate that through another call through XCB called generate ID. We pass it the connection, and that is what we are storing off as our XCB window. Okay, so the next thing that we need to do is we need to register what types of events we want to listen for, right? Now, if you recall on the Windows side, we actually had an event loop, right? So actually, if we pull this up here, we have these events here that basically peak our event stack, right? And so Linux actually has a similar sort of event stack that exists. However, in order to actually receive those events, you have to register what types of events you want to listen to. And so rather than sort of piecemealing this, I'm going to sort of enable everything that we're going to need right off the bat from the get-go so that we don't have to come back to this code. Okay. Our event mask is basically going to consist of our XCB CW backpixel, which is basically saying when we're filling the window with a single color, that's what we're going to use. So we're actually going to black out the window. And then this mask right here is basically an event mask that's always required. We always have to pass it no matter what. So here's our event mask, and here's the event values. So these are all the different events that we want to listen for. So button press and button release, those are the mouse buttons. Key press, key release, those are for the keyboard. Exposure is, if I recall correctly, that has to do with the window minimizing and maximizing. The mask pointer motion, that is for mouse movement. And then the event mask structure notify is, I want to say, for closure events, if I recall correctly. Again, this was kind of hard to look up the documentation on this, but these are the events that I've found that I have wound up needing. So these are the ones that we're going to go ahead and register for. So the next thing we need to do is set up a quick array of some values to be sent over to XCB. And so those two values are the background color and then our events that we have set up here. So as I said before, we're going to black out the screen. And so we're going to say state screen black pixel, which basically says this is the color of pixel that we're going to use for the background here. And then the event values is our sort of ORed together bit fields here. We're going to jam that into an array and pass it through as this value list array here. The next thing that we need to do is actually create the window. So creating the window returns something called a cookie, which is a little bit strange to me, but I don't know why they call it that. I don't know why they don't just call it window, but when you call XCB create window, it returns a XCB void cookie. Again, it's a little bit strange, but it is what it is. So it takes in the connection, the depth. I'm just going to pass in from the parent because we don't really care about that. We don't need it. Takes the state window, the root screen, which from my understanding is just the parent screen. According to my comments that I've got here, it basically is just saying when we create the window that we're basically going to assign it to the root sort of element in the screen space. We're going to pass the X position, Y position, width, height. We're going to say that there's no border on our window because we don't want a border on it. Our window class is basically saying that we are going to accept input and output, or we're going to accept input and also output. Window events is my best understanding of this. And then we're passing some visual information here, sort of the root visual. I'm not sure why this has to be passed similar to this. Again, I'm no expert on this API, but the important thing here is we have our event mask, which is set up here that we're passing through, and then we have our value list, which is this array that we've set up here. So those are the most important parts of this, right? So here's our window creation. And then we need to go ahead and set the title of the window, because you notice in this, when we create the window, we don't actually set the title of it. So that is a separate call to XCB change property. And again, we pass it the connection. And in this case, we're replacing the property with another one. We're saying we're going to affect the window that we've saved off. Here is where we're saying we set the window name to a string, or it's the data type that we are accepting. And here's where we're saying basically the data should be viewed 8 bits at a time. Now, it's a little bit weird that they go by bits. I don't know when that would ever be less than 8 because we're passing a string. Each one of those is 1 byte, which is 8 bits. Anyway, that should be string length application name. And so our application name here is basically the one that is passed in here. So when we create this, we're just saying we're going to use the application name as the actual title. So we get the length of that here. Here's the string length, and then the actual string itself. So the next thing that we need to do is anytime the server attempts to destroy the window, which can happen from some OS event or otherwise, such as shutting down, for example, we need to tell the server that, hey, it needs to notify this client whenever that happens, because that does not happen by default. And so that is what all this code does here. So we basically have a couple of methods here to basically listen for the delete window message, also the protocols message, and then also we retrieve some function pointers to the delete and protocols methods themselves. So you can think of these as a sort of window procedure that gets called whenever these things are received. So here's what we're saying. This is what we're listening for here and here. And then this is saying here are function pointers for those things. Okay. And then here we're just saving off a copy of those things. Okay. So similar to this call up here for changing the window title, we are actually going to change some of the callbacks. So this is basically, again, we're replacing on the window our reply and our delete is my best understanding of this. Again, this is not something that was heavily documented, so I know this works, but I'm not 100% sure as to how all this works under the hood, because there's not really good documentation out there. So if any of you guys happen to know a little bit more detail about this and can explain it, feel free to do so, and I can always append an explanation to this later. So the next thing we need to do after that is we actually need to map the window to the screen. So that's just a simple call to XCB map window. We pass the connection and the window, and it maps it to the screen that we got up here in our iterator, right? This guy right here. Simple enough. So once we've done that, then we need to basically flush the stream. And this is similar to a command console or a web request or anything like that. When you flush the stream, you're basically saying, okay, make sure that anything that's currently buffered in the stream gets output so that we've received all the data. Okay, and so we do that with a simple call to XCB flush, and we want to make sure that whatever, and so if we if we actually look at the tooltip here, we'll see that anything greater than 0 is a success, anything less than or equal to 0 is a failure, right? So it forces any buffered output to be written to the server, blocks until the write is complete, right? So this is a pretty quick request, but it's something that has to be done before you can actually close this off. And finally, that is everything that we need to do to actually set up our window. So if we were to run this now, we would actually get a window that popped up for us. But we're not going to do that yet because we need to go through here and finish filling out the rest of these methods. Thankfully, most of them are actually pretty short by comparison, with the exception of some input stuff. So our shutdown is actually going to be pretty simple. So first we need to cold cast our internal state. I know that some of you guys mentioned in the comments that we could have just kept platform state as, as internal to this file, similar to how we did with this internal state. But there are other things that we're eventually going to store in this platform state that I need to be public. So I actually can't do that. So I need to stick with this pattern, but I just wanted to sort of address that real quick. Okay. And so first thing we're going to do, like I said, is cold cast. If you recall up here, we turned off our auto repeat, and that is global. So when we shut this down, we actually need to make sure that we re-enable that by just calling X auto repeat on. And then finally, we need to just call XCB destroy window and pass it the connection and window. And that is pretty much it in terms of shutdown. So it's pretty straightforward stuff. Okay. So next, I'm going to go ahead and just kind of stub out our pump messages here. So if you recall in our Windows platform, we had a sort of message loop with an internal while loop to make sure that we cleared the message stack every single time. And this is actually going to wind up being almost the exact same thing. So in order to kick this off, obviously we first need to cold cast to our known state type. And then I'm going to create a couple variables here just to track things. So we have a pointer to an event, and then a actual message event as well, a pointer to one of those. And then we have this Boolean here as to whether or not a quit has been flagged. Okay, so the very first thing we need to do is we need to create a while loop to pull for the events, right? And so our while loop is actually going to look like this. And so what we have here is basically we're saying while the event is not equal to 0 or a null pointer. And so we're going to set on every iteration event equals XCB pull for event, right? And we're going to pass it the connection. And so basically if we ever have event gets returned as 0, meaning that we do not have any events to process, then we're going to break out of this loop. And so this is just sort of a safeguard to allow us to break out of the loop in case for some reason we accidentally call this down further or something like that and don't catch it. So anyway, that is how we pull for the event. And similar to how we did on the Windows platform, we're going to switch on that event. And we're going to look at the event response type. And according to the documentation, we actually need to check this by ANDing it with the inverted bitwise operation against O0x80. And basically what this is it's taking this 0x80 and it's flipping all of the bits to be the inverse of what they are for 0x80. And then it's saying, take this event and AND it with that. And what that's going to give us is the actual code that we need to process. I don't understand why they made it so complicated and that you have to do it this way, but that is just the standard way of doing it to the best of my understanding. And so what we're going to do here is I'm just going to stub out all the different types. So we have our XCB key press and release. Again, those are for keyboard presses and releases. So I'll just go ahead and put a break here. Right, and when we're ready to actually handle input events, we'll go ahead and fill that out because we're going to want to do some extra logic here on the Linux side to handle things. So input will actually be handled in another video. And then next we have the button press and button release. That's for the mouse buttons. So we have mouse button presses and releases. And again, there will be logic that we'll need to add for that once we get to input. And then the next thing that we'll need is this notify. Which is actually for handling mouse movement. And so once we are to the point where we'll be doing mouse movement, we'll need to fill that out as well. And then we have the case of XCB configure notify. So this has to do with resizing, and since we haven't really covered that on the Windows side yet, I'll go ahead and leave this to do as well for now. In fact, these are all technically to do, so let me go ahead and mark them as such. Okay, so this is basically how to handle a resize. And the one that we're actually going to wind up handling in this video is this XCB client message. Okay. And this is actually going to handle window closure requests, right? So in this case, we want to save off the client message by casting the event to a client message event. And then we can take the data 32, which is basically an integer, and say if that equals the code that we saved off for our window deletion, then we'll say quit flagged equals true. And so this is basically if the close button has been hit. Then that is when that will be invoked. So I'll go ahead and break there. And then, of course, we should, by good practice, have a default case in here. If something else has happened, then we'll go ahead and handle that. So one thing that we need to do at the end of this switch is every time we pull for event, unfortunately, event, our pointer here, is dynamically allocated. And I'm not sure why they did it this way. It is suboptimal, in my opinion, to be dynamically allocating on every iteration of this. That kind of sucks, but we don't really have a way around it. So unfortunately, that means that down here at the end of the switch statement, we have to free the event. Not ideal, but as far as I'm aware, there's not any way around it. So we have to be sure to free that when we're done with it. Okay, and then all we have left for our pump messages is to return whether or not we should quit. So our quit flagged could be set here. And so we want to return not quit flagged. And so basically if quit was flagged, then we're going to return false. If quit was not flagged, then we're going to return true. And that is pretty much it as far as the pump messages goes. Again, we're going to have to come back and fill all this stuff out in the future. Okay, now to some simple things. So allocate, similar to how we did on Win32, temporarily, we're just going to call malloc and return it. Free is going to wind up being the same thing. And then platform zero memory is again going to be similar to how it is on Windows. We're just going to call memset and set the block to 0. Copy memory is just going to call memcopy, and memset is going to be used for platform set memory. And again, we are going to come back and put some platform specific code in here so we can handle memory alignment and some of those things, but we're not going to handle that right now. Okay, so the last piece of this, or the last couple pieces of this are relatively simple, but that is the console write and console write error. And so if you recall with our logger, we have our various levels of logging, right? We have our fatal, error, warn, info, debug, trace. And on Win32, we actually set up an array of levels and use these sort of predefined indexes of color configurations. And we're going to wind up doing something kind of similar to this with an array on Linux, although it's going to operate a little bit differently. So what we're actually going to use is color escape codes. And these are things that are accepted in terminals in most operating systems, except Windows, of course. And so this will actually wind up working on Mac as well, I believe. But basically, there are these color codes where we say what we're changing the background and foreground color to. And these are the color schemes that I have come up with for that. So again, they align with each one of these levels here. So if you guys want to change these, feel free to. If you want to look up these codes, feel free to. But basically, the way this works is we are going to be using printf, but it's going to have some escape codes in it. So the way that this works is we have \033 and then an open square bracket. And that is a escape code to say, hey, we're going to change the color of the following text, right? And then we have a replacement code here for a string where we're actually going to pass the color that we're going to use, right? So it's going to pick one of these strings here. And this changes the foreground and the background color of what we want to actually use. And then after we do that, M actually marks the end of this escape sequence, right? So the escape sequence contains all of this, then one of these combinations here, and then the M character. And that's the last bit of that escape sequence. So once you reach the M, everything after that is actually text that will get written out. So we write out another string here, which is the actual message itself. And then we have another escape sequence here where we say \033 open square bracket 0M. And the 0 code here basically says reset everything back to normal. So what this section is doing is this is basically setting a color. It's saying change the color of the text, then print the text, then change it back to normal. And we're going to do this every time we log text. That way we don't permanently change the console. We have text set only for text color set rather only for this particular log. Pretty straightforward stuff, I think, once it's explained, but it takes a while to figure out how to actually put this together. So that's how that works. Now, the beauty of this is we are actually going to use this same exact code for console write error. Because in this case, we don't have a separate stream for that. We could use a separate stream for it. In this case, I don't think I'm going to bother. I'm just going to use the standard output for that. I may come back and change it at some point, but for now, this is fine. So, two more things. We have our platform get absolute time. And for this, we're actually going to use something called time spec. So we need a struct time spec, and that is actually going to be, we're going to call that now. And then we're going to call a method called clock get time. And we're going to pass this clock monotonic and then the address of now, and it's going to fill out that structure. And then clock get time actually returns both seconds and nanoseconds. And so what we're actually going to do is we are going to take the nanoseconds and we are going to multiply that by this number, which is basically going to perform a little bit faster division, if you will. And it's going to take those nanoseconds and convert it down to a double, which is how much of a second that actually represents. And then it's going to add it to the seconds here. So it's going to return essentially a double, which is an F64 of this, which would be the now seconds plus the nanoseconds scaled 2 seconds. So this is going to give us a pretty accurate timer that we can then use in a similar way to how we use the same timer from Windows. So this allows us to basically always deal with seconds instead of having to deal with separate units of time per platform. So that's how we accomplish that here. Okay. So sleep is the last thing that we're actually going to be filling out here. And sleep is kind of complicated because of this whole situation up here. Depending on which one of these we use, the call is also going to be different because this is unfortunately not something that's standard across all Linux distributions. Some distributions may have one, some may have the other, so we need to cover both. And so I'm just going to paste in some code here. So we're using this same POSIX C source that we use up here at the top, right? And that is if we are using nanosleep, right? So if that's the case, we get another time spec. We take the seconds and the nanoseconds and we perform the similar operations that we performed up here. And then we call nanosleep, which ultimately uses this time spec that we fill out. For some reason, VS Code is actually highlighting this as the active one, but on my distribution, for some reason, this is actually the active one. So I'm not sure why that is. You guys may see the same. If anybody happens to know a little bit more about how this works, that would be great. But what we do here is this is actually the one we'll wind up using at least on Ubuntu. Some other distros may wind up using this code down here. So if we use this code down here, we're basically saying if the milliseconds passed is greater than 1,000, then we want to divide that by 1,000 and call sleep. Otherwise, we're going to call uSleep by modding it by 1,000 and then multiplying it by 1,000. Either way, what this will result in is us sleeping for the number of milliseconds that are passed here. The details of that aren't quite as important, so I'm not going to do a deep dive into that because I don't want to spend this whole video talking about POSIX sleep timers or non-POSIX sleep timers. The other thing that's a little bit weird is VS Code does highlight this as an error, but it's not actually an error. I'm guessing it's because I'm not pointing to a header file in the CPP configuration, and I've yet to figure out what exactly is going on in there. So for some reason, this is acting a little bit like a fool, but it compiles and works. So with that said, I'm actually going to go ahead and build. And we can see here that our assembly was built successfully. So at this point, if we run, we can take a look at a couple things. Before I actually start up the platform, I'm going to show you guys the various logging that we have here. So I'll just step over these real quick. So you can see our fatal there, our error, our warning, info, debug, and trace, right? So we know those things are working properly. We have our nice colored output just like we do on Windows. And now I'm going to go ahead and continue the application. And we have our black window as we expected. So it's taken in our title here. We can move this around. We can resize it. We can do whatever we want. And we have our window. So our platform layer, at least for now, is complete. Until we get ready to actually handle input, then we'll have to revisit this on both operating systems. Whenever we get ready to handle input, I'll probably wind up doing both in the same video versus splitting them out just to sort of get it knocked out. But that will come in the future. So I'm hoping at least in the short term, we can kind of get away from platform specific stuff for a little bit and actually start building out a little bit more of our engine structure. Most notably, next time we are actually going to be setting up our application layer and having a proper game and application loop. So with that, thank you guys so much for watching. If you haven't already, hit the like button, consider subscribing, hit the little bell notification there to get notifications as to when the next video in this series drops. And feel free to leave a comment below. If you, again, I'm not an expert on any of these APIs for Linux. I don't spend a lot of time on them because I want to get away from platform-specific code as quickly as possible. So if any of you guys are experts on that or see things that could use changing or fixing, please drop a comment below and I will address it. Anyway, guys, thank you so much, and I appreciate you guys, and I will see you in the next video.